Welcome to this course in trigonometry. In this 12-week course, we're going to cover 4 chapters in the OpenStax pre-calculus textbook. Those are chapters 5, 6, 7, and 8. Chapter 5 is about trigonometric functions, specifically about angles, sine, cosine, and the other trigonometric functions, the unit circle, and right triangle trigonometry. Chapter 6 is about periodic functions. These are the same functions as we will have talked about in Chapter 5, but in Chapter 6 we're going to look at them from a slightly different perspective. We'll also look at graphing them, and we'll look at their inverses. You should be familiar with inverses from a course in Precalculus 1 or Algebra 2. In Chapter 7, we'll talk about trigonometric identities and trigonometric equations. Identities are just special equations. They're actually claims that we make that one side of our equation is equal to the other side, and it's going to be our job, along with some other tasks in this chapter, to prove those identities, and I'll give you some strategies about how to do that. In Chapter 7, we'll also be talking about trigonometric formulas. These formulas are used to solve more challenging trigonometric equations. And these formulas are kind of a segue between how to prove identities in general and how to solve trigonometric equations. These formulas, will be proving some of these formulas, some of these equations, some of these identities in the first part of Chapter 7. And the last part of Chapter 7 will be using them to actually solve those equations. Finally, in Chapter 8, we're going to be looking at applications. Now, applications, the word applications usually strikes fear and terror into the hearts of many students. But in this case, although we will be doing some sort of typical word problem style applications, we're also going to be looking at some applications of how trigonometry can be used to solve mathematical problems. In other words, we're actually going to be using some formulas in a way to solve problems that we couldn't solve if we didn't know some trigonometry. Lastly, we're going to be looking, still in Chapter 8, at polar coordinates and polar graphs, and at parametric equations. And those are kind of hard to describe in a really short video like this, so I'm just going to leave it as it is, and know that when we get to Chapter 8, I'll give you a great deal more detail about what you actually need to know for those concepts. Each one of these chapters is broken down into several sections. In Chapter 5, there are 4 different sections. In Chapter 6, there are 3. That's really not very many. In Chapter 7, we have 6 sections. And in Chapter 8, there are 8 sections. So the way I'm going to break down this course is to keep chapters 5 and 6 together. We're going to treat that as one module or one unit. The ideas here, trigonometric functions and periodic functions, are very, very closely related anyway. And so if we treat this as one module, and then identities and equations as a separate module, and applications as a third module, each of the modules will have about the same number of sections in them. For each section, my plan is to create one short video. Now, there's a lot of content in a single section. So while my goal is to keep those videos short, they may end up being longer than you or I would really like. So please try to bear with me as we work through this content together. I have to try to strike a balance between how short the video is so that you will actually watch it all the way through and get a basic idea, and how much content, how much detail I go into so that you'll actually leave the video having watched it with at least a basic understanding of everything you need for that section. So while my goal is to keep the videos short, I'm not going to promise to keep them all under 10 minutes. As much as I'd like that, I'm just going to aim for that and hope for the best. With what's left of this video, I want to go over just a couple of very brief ideas that hopefully you will remember from geometry. But for some students, I know geometry was a long time ago, and for others, it was just a part of taking math that didn't quite fit in with the rest of what you knew how to do. And so it may have felt a little bit foreign, it may have felt a little bit outside the norm, if you will. So here are some basic ideas from geometry that are going to be very, very important as we uncover the knowledge we need in trigonometry. So the first of these is, what is a point? A point is usually represented by a small dot. Unfortunately, that description or representation is already pretty inaccurate. A point, as described in geometry, is, well, it's a point. It's really hard to call it anything else. But it's so infinitesimally small that there's no way to actually see it, even with the strongest microscope. So the point, that the dot that we put on the paper or on the whiteboard, is just there to give us a sense of where we are in relation to other things. For example, if I was looking at a distance, I might put another point down so that I could talk about the distance between those 2 points, right? So a point is an infinitesimally small piece of space. I mean, that's really the only way to describe it. When we get into higher levels of calculus, we'll start talking about space in the sense that we use it in the real world. We might be able to describe, for example, a point that is a certain distance out from the origin in the x direction, a certain distance out in the y direction, and then also a certain distance up in what we call the z direction. And that gives us a point in space, in three-dimensional space, right? Well, you don't need to panic because in this class we're going to stick to two-dimensional space. So everything we describe will be distances between 2 points on a plane. And a plane is just, well, an example of a plane is the whiteboard or a chalkboard or a piece of paper or the top of your desk. Okay, the next thing we often learn about in geometry, or at least we learn it at some point, is what is a line. I'm going to draw what looks like a line here. Notice that the line that I'm drawing has arrows at either end because by definition, lines go on in both directions forever. But what is a line, really? In terms of defining what a line is, it's just a series of points. And in fact, the points are infinitesimally small and infinitesimally close together. I don't know if you can see that I'm drawing these points in between other points that I already have on my line. The point is, no pun intended, that a line is a collection of points that meet a certain criteria. In algebra, we learned that that criteria was that on some graph, the y value of 1 point was always going to be equal to some ratio we called slope times the input value x plus or minus some constant value. Okay, so we have this equation of a line, and that's a great way to describe it in algebra. There's an overlap with geometry, but in general, in geometry, we talk about a line as just being this collection of points that all meet a criteria. We don't tend to use this description as much in geometry, but that's where the overlap is. We take this understanding of what it means to be a line and we apply it to the idea that there's some kind of a slope here and there might be a set of axes somewhere. We don't know where that is, right? And so a line, in terms of geometry, is just a collection of points. I want to have a nice, neat record here when we're done. So I'm going to redraw my line, but I want to make the point, again, sorry, no pun intended, that since lines are collections of points, and points are infinitesimally small, lines are also infinitesimally thin, if you will. You can't actually see a line because it's so thin that even the strongest microscope, you could keep zooming in and zooming in and zooming in, and you'd never actually be able to see it. So the line that I've drawn on the page here is really just a representation of a line. It's going to help me visualize what's happening in the world that I'm working in, but it's not an actual line because it's too big. Now, a line goes on forever in both directions. So if I want to say that I'm cutting it in half, I can literally do that anywhere because it goes on literally forever in both directions. It's infinitely long, so there's no real halfway point. If I take a line from some point onward, like this, I'm going to call that a ray. And one way to think of a ray is as half of a line. It goes on in this direction forever, but it starts, or you could think of it as ending here, but I think of it as starting at a point and then going on forever in one direction. Now, lines, let me get the right pen here, lines can go in any direction. Rays have the same property. I could have a ray that started here and went back this way, or I could have a ray that started here and went down like this. Okay, these are all rays in the same way that these are all lines. So that's important to keep in mind, but the idea of a ray is just that it's half of a line. And where's the halfway point? Well, it can be anywhere, but since it goes on forever, we might be defining where the line starts and then saying it goes on forever. Now, for the last part of this introductory video, I'm going to introduce the idea of an angle, but we're going to be talking about this in our first video of the course, which is section 5.1. But just to give you an idea, just to kind of close out this introductory video, I'm going to say that an angle is any two rays, like for example that one and that one, but where those two rays, sorry, I had the wrong tool there, where those two rays share a common starting point. We call that an end point, but where they share that common point where they both start. Before I had put those together, those were just two rays, but when I put them together, that is when it becomes an angle. And when I say it becomes an angle, I mean this entire collection of two rays with a common endpoint. That whole thing is an angle. There are actually two angles here. This is kind of interesting. There's this one here that starts at one ray and goes to the other. But there's also one that starts at the other ray and goes around to what feels like the first one or the lower one, right? So there's a large angle there and there's a small angle there. Together, they're going to be 360 degrees because together they make up a full circle. But that's enough for this video. I just wanted to put in some time with some introductory ideas. We're going to start section 5.1 with the idea of an angle specifically in standard position. So we'll start section 5.1 with that when the quarter actually begins. But until then, I hope this has been helpful in reviewing some basic geometry ideas, and I'm looking forward to working with you in the rest of the course.